Hi. So these are the solutions and the marking schedule for the Year 12 Mathematics Extension Task 1 for 2024. So there was 1 hour for the task, and I think we got a little bit more than an hour. We got about 5 minutes extra because everyone needed some more time. The paper is on mathematical induction and vectors. Section 1 was multiple choice. They were just worth 1 mark each. So the first answer is A. Which of the following is not generally a step in mathematical induction? Well, we prove the first step, which is n equals 1, and then we assume the n equals k step. So we don't prove that. So that is not a part of induction. The second question, we had to prove this induction statement for all integers greater than or equal to 1. Which of the following has an incorrect expression for the part of the induction step? Okay, so this one has an incorrect step. Just be careful that you've actually read that as incorrect, because we're assuming the result true for n equals k. And if you have a look up here, we've got 1/3 of n, and here we've got 1/3 of k plus 1. So this step has actually popped k plus 1 into that part of it. So that's why that one is incorrect. Okay, 3 is nice and easy. A vector can be represented by both magnitude and direction. For 4, this one's actually a past HSC question. So all you want to do is pop in, I haven't popped the answers in there, but you're just going to use a formula straight from the HSC formula sheet, looking at the dot product of those two vectors is equal to the magnitude of that vector times the magnitude of that vector times cos of the angle between it. So if you pop that in, that answer there is going to fall straight out. So that's another nice simple one. Part 5, given that vector OA is 8 minus 3, so that's that vector down there, OA, and OB is 3i 2j, so that's that one up there, OB. What is the vector AB? I generally recommend drawing yourself a diagram for these ones, even if it's only a sketch. So in doing that, I can see that vector AB is going to be OB minus OA. You might want to write that as OA plus AB equals OB and rearrange it. But that's the equation that we're going to end up with. So we're just going to look at the x components, additioning those, or subtracting those, sorry, and the y components, subtract those, and we end up with minus 5a plus 5j, which is b. Okay. Love this last question. Okay, I'm going to zoom in on the solutions there, but it says consider the vectors a is mi plus j and b is I plus mj, where m is a real number. Find the possible values of m given that the angle between a and b is 30 degrees. Now, it sounds horrible, but it's not horrible. All we're doing is exactly the same basically as we did up above in question 4. It's just, I guess, a little bit harder because we've got m's and i's and j's and letters coming out everywhere. So what we want to do is look at work out what the dot product of our two vectors are. Okay. We're going to have, remember it's xx and yy, so we're going to have m plus m. So we're going to have 2m for that dot product. We're going to work out also that the dot product is equal to the magnitude of each vector times cos, and they've given us that the angle between is 30. So if we pop that in, we're going to end up with this, okay, equal to 2m. So we've got this equation here, and then you've just got algebra, okay. I'm not going to go through that now, but working that through, what we're going to end up with is these two solutions here. So love this question. I think most of you got it out, which was really good. And from memory, that may have been a past HSC question as well. I can't remember. Okay, so that was out of 6. They were our 6 multiple choice questions. Okay, so going on to the second section. The second section is out of 24 marks, not out of 25 marks, as it says there. Okay, that's out of 24, because the first was out of 6. Okay, so the first section is out of 15. So we've been given two vectors, a and b. We're calling them OA and OB, 8i minus 6j, 1 plus 7i. And basically all you're doing is finding a whole heap of information about that. The first thing is the column vector. We're just writing a as a column vector. Remember, all we do is just get the values out the front of the I and the j. We've got an 8 and a -6. We write it as a column. That's our first answer. Part 2 is find the, and mine might be a little bit different to yours there because I've just handwritten that in there, but we're finding the unit vector of A. Now, the unit vector is the vector A divided by the magnitude of the vector. Okay, so we get out vector A. Sorry about my writing being so small there. And we divide that by the magnitude of that vector A, which is the square root of the square of each of the parts in that. So 8i minus 6j divided by 10. I've just broken that 10 up into each part, and we've got 4/5 I minus 3/5 j. Okay, let's have a look at our third one. The magnitude of B. I think yours might have had B in as part 2 and A as part 3. The magnitude of B is just the square root of each of the parts of our vector B. Noting that our vector B is I plus 7j, so it's going to be 1 squared plus 7 squared. We're going to have 1 plus 49, which is root 50. Okay, 4, 3a minus 2b. We're basically just timesing the vector A by 3. So that would be 24i minus 18j. Timesing the vector B by 2, 2i plus 14j. And then we just want to subtract them. So our resultant vector is 22i minus 32j. Part 5 is just the dot product. Remembering that that's on our formula sheet. So the dot product of two vectors is the x components added together with the y components. And we end up with a value in that case, not a vector form. That would be 8 times 1, which is 8, plus minus 6 times 7, which is minus 42. So that dot product is minus 34. I think the projection was probably the hardest one of this because we don't have that formula on our formula sheet. But the projection of B onto A, I always write that as B onto A, is A dot B times the vector A over the magnitude of that vector squared. So the vector that we're projecting onto happens 3 times in that formula. The vector that we're from is only once. So just note that you need to memorize that formula, okay? Popping that in there, we've got A dot B from above, that's minus 34. We've got the magnitude of A squared. Have we got that somewhere up there? No, but we can work that bit out, easy. 64 plus 36 square root is, and squared is going to be 100. And we're going to times that by that vector. So we've got minus 34 and 100 times 8i, minus 34 and 100 times minus 6j. Note, negative is going to give us a positive. So just be really careful there because some of you forgot that. Each of those was worth 1 mark. Okay, part B. Find the values of x such that the two vectors u and v, given here, are perpendicular. Okay, so where previously everything was basically worth 1 mark, here we're looking at making sure that we're getting this looked at. Hang on, let me just pause that for a second. I'll start that again. I wanted to have a look at the marking schedule here. So everything was worth 1 mark previously. Here you got 2 marks if you had your working shown and you got the correct answer, and 1 mark for a partially correct question in that case. So the keyword here is perpendicular. So noting, do vectors are perpendicular if they have a dot product of 0. So u and v, dot product of 0. We're timesing our x's. X times x minus 7 plus 2 times 4x minus 1 equals 0. You get a quadratic. We factorize our quadratic, solve our quadratic, and we get x is equal to minus 2 and x is equal to 1. I think we had a couple of people getting one of those answers only, so you need to show me my working out and give me those both answers to get your results, which was out of 2. Okay, part C. Well, our previous question was perpendicular. This one is parallel. So we've got two vectors, A and B. They're parallel. We want to find y. Y is unknown in vector A. Again, a 2 marker. 2 marks for working correctly. 1 mark if you partially got the right correct working out. Now, the ways that I have done these are just my ways. Maybe there's simpler ways. Maybe there's other ways. If you've done them other ways and you've shown your working and you've got the right answer, you've got the marks as well. Okay, so I've got an alternative solution here because there is an alternative solution. And I think someone in our class did a really amazing solution, but I was really impressed with, and I might pop that up there later. So if vectors are parallel, then their dot product is equal to the magnitude of each of them multiplied together. So the dot product of A and B is going to be minus 6 times 2 plus y times minus 4. So we're timesing our x's and timesing our y. So we get minus 12 minus 4y. The magnitude of vector A is the square root of each of the components squared together. So that would be minus 6 squared plus y squared. Hence the square root of 36 plus y squared. The magnitude of vector B, again like before, is the square root of each of the components squared and added together. So we get 4 plus 16. And that's written as root 20, or I'm going to write it as 2 root 5. So I think if you did that much, I probably gave you a mark if you got down to that point and put some information in that showed me that you knew what it was for vectors to be parallel. But we also want to write our answers in that format. So A dot B is here. I'll zoom in a little bit there. And my magnitudes times together is here. From now on, it's a lot of algebra. So what I did was factorize a 2 out of this side here. A 2 or a minus 2, either way. And then that 2 I've cancelled with the 2 on the other side. So I've ended up with a 6 plus 2y on this side and a 36 plus y on that side. I squared both sides, getting rid of the square on this side, getting rid of the single here and getting a squared. But noting when I square root 5, I get a 5. So that's what I've got there. You may have done it slightly different. All I've done then is open this bracket, square the first, square the last, twice the first times the second. And I've also multiplied by the 5. Gathered like terms. I pulled everything to the right-hand side here, and that was my quadratic that I got. Being careful that is a negative. I think we have people with a positive in there, so be really careful. And I got y minus 12, y minus 12. So it's a perfect square. Solving that, we get y equal to 12 as our solution. So mark-wise, you needed to get the y equals 12 and show me you're working out to get your full marks. If you made a mistake along the way or you didn't get the whole way, you would have lost a mark for that one. Okay, so part D is a proof. To get the proof out, you would have got 3 marks. You would have got 2 marks for attempting to use the dot product formula equal to 0 because we're looking at perpendicular here. And 1 mark for showing results for vectors CA and BH. So as long as in this question you've given it a go and put down as much information as you can, you would have at least got 1 mark out of that 3. So let's read the question. So the 3 points A, B, and C are chosen on a circle centered O. Vector A is OA. Okay, so if you need to put your arrows in there, do that. So going to be up, and there is an arrow in there. Vector B is OB, okay, in that direction, and vector C is OC. We're going to let H be the sum of A and B and C. So we can't draw that in there, but we might need to use that at some point along the way. And let H be the point such that OH is equal to vector H. So all that's on there. What we want to do is we want to show that BH, so that's that one there, and CA, that one up there, and so I put an arrow in that direction, are perpendicular. So from the diagram, we can't really do much in there at this point. Let's write down what we know, and let's make some triangles out of the triangles that we do know and see what we can do. Okay, so to show that these guys are perpendicular, we need to show that their dot product is equal to 0. Okay, so perpendicular dot product is equal to 0. Okay, so remembering that is the case, is if you look at the dot product rule, the dot product of 2 vectors is equal to the magnitude of those vectors times together times cos of the angle between them, or cos of theta. If the 2 vectors are perpendicular, the angle between them is 90, cos of theta is 0, hence the dot product is 0. So that's where it comes from. You just need to memorize that or understand what's happening and write that in. So I'll shrink that down so we can see what I've got. So I'm starting on the left-hand side here. So with these questions, don't jump in and go, I can't do it, it's too hard. Let's look at what we know. So we know that OC, this vector here, OC plus CA is equal to OA. So OC is C. CA we don't have another number for yet, but as you can see, that's what we want to deal with at the top. Okay, so we want to keep that as CA. And that equals OA, and OA is A. So we've got this. Rearranging, CA is A minus C. Okay, so if you got that vector and a resultant for BH, you would have got a mark. So that showed me that you know something at least. And what else do we know in that question? I'll zoom out a little bit more. Okay, so we know that OB and BH is OH. So just looking at the triangles, OB plus BH has a resultant of OH. OB is B, OH is H. So we know that BH is H minus B. So if you got something out for those two, okay, I would have given you a mark for that, even if you didn't go on to deal with anything else. Okay, so let's see what we can do with those two. So one's got an A and a C, one's got a H and a B. Too many variables for my liking, okay? So I've used the result at the top that H is equal to A plus B plus C. So let's sub this into 2, okay? So replacing that H with A plus B plus C up here, minus B gives us BH is A plus C. So there's a new formula for BH. Now, we now have something for AC in terms of A and C. We now have something for BH in terms of A and C. Let's do the dot product of those two up here, and we want to show that that's 0. If we show that it's 0, then it's perpendicular. The dot product of those two vectors, we multiply, like we're basically opening our brackets, but when we're doing that, we're dotting between the two. So A dot A plus A dot C minus A dot C minus C dot C. These guys cancel. We've got A dot A minus C dot C. Now, what we learned in class was that when we're putting two vectors together, the dot product of two identical vectors is the magnitude of those vectors squared. Okay, I can go into why that is. It's because they're parallel vectors. There's no angle between them. So that bit goes to 1. So it's basically the dot product of two vectors is the magnitude times the magnitude. So there's two magnitudes, or the magnitude squared. I can go over that in class if you need to let me do that again. So the same for the C. Okay, so the magnitude of A squared minus the magnitude of C squared is 0. Since A and C are the radii of the circle, the magnitude of A and the magnitude of C is the same. Therefore, this is equal to this, which means that when we subtract them, we get 0. So these guys are perpendicular. So something along that line, working down to here, is what I wanted for your 3 marks. Okay, if you attempted, after having found what CA and B are, attempted to find the dot product up here, doing something in there, and you've attempted to do that, you would have got 2 marks. Okay, but that was a 3-mark question. Overall, that was done pretty well. Okay, this one's blue. So part E is looking at it's a 2-mark question. Now, there was a little bit of controversy over this, and I just want to clear this up because this is something we need to make sure that we can do. So 2 marks for the correct solution, 1 mark if you partially got that right. So what you need to understand is really think about what a vector is when you're looking at this diagram. So in this diagram, we've got L and O and M being the diameter of that circle, and N is some point on the circumference. You might have seen this proof where we had to show that this angle here was 90 degrees. We don't want to do that. It's a lot simpler than that. It's telling us that vector R is ON. Okay, so make sure your directions are right. So this is R, this is ON. S is the vector MN going that way. And we want to express LN, which is this one up here in that direction, in terms of R and S. Now, we need to get something clear here. Yes, OL, OM, and ON are all radii of the circle. So if we were to work out their magnitude, okay, they would have the same magnitude. But they are not all the same vector, and they are not all equal to R. Remember, a vector has magnitude and direction. This vector here, ON, which is R, it is going in a different direction to this vector here and this vector here. So they are not all equal to R. Their magnitude would all be the same. So just be really careful because that caused a little bit of confusion with this question. Okay, what we do know is that OM and OL, because they both go through the center of the circle, those two vectors are equal but in an opposite direction. So I know that OM is equal to the negative of OL. If you wanted to run a vector from L to O is equal to vector O to M. And also, L to M is double the vector O to M. So they're all the things that we do know. Now, this question can be done lots of different ways. I've got a way down below that I've done it, but I might do another one for us just up here. Okay. So we know that OM, this one here, plus MN is equal to ON. Just working in that triangle there. That gives us a relationship between R and S. So therefore, OM plus S equals R. So I can write OM as R minus S. And that's that one there. Now, I'm going to give you an OR version down here that I'm going to work on. That's going to be, and there's another one down below here. But let's look at this one. So if I was then to have a think about this great big triangle here, I want a relationship for LN. And I know that LN, okay, is the resultant vector for LM plus MN. So LM plus MN. So LN is what we want to find. LM, we talked about this right at the start. So L to M is twice the length of O to M. So that is 2 lots of vector R minus S. And we know that M to N is S. So if I just multiply out by 2, I'm going to have 2R minus 2S plus S. So that's 2R minus S. And that's an answer for vector Ln. That's one way. Another way you could do it is what I've done along here and said that, oops, I'll just quickly do that. So I've still got that relationship, that OM, there is R minus S. But we also know that working in the other triangle, OL plus LN is equal to R. So if you thought of it like that, you might have said, well, LN down here, where are we, is R minus OL. We know OL is the opposite direction to OM. Oops, sorry, my screen's got a bit funny there. So we know this relationship here, so I can pop LN is equal to R plus OM. I've replaced my minus OL with OM. I could do it that way. And in which case then I would sub my equation 1 up here into this one down here. So I'd have R plus R minus S, so 2R minus S. That's another way of doing it. So there's obviously options, but you need to be really, really careful, especially when you're working within a circle, that yes, they're all R. If you were looking in circle geometry and we were looking in magnitude or distance, that would be the case. But with vectors, we're looking in direction. So you need to be really careful about that. Okay, next part. Mathematical induction. These were all worth 3 marks each. I'm not going to go through all of it verbally because I think we've got the answers here and it will be very boring to go through all of it verbally. 3 marks if you got the correct solution, showed all of the steps. 2 marks if you did get through all of it but you attempted the n equals k plus 1 step and tried to get that out, and only 1 mark if you gave it a go and you got the first bit out. Okay, so remembering, I want you to put these steps in here that are in blue. If you don't have those in, then you haven't done it correctly. So I want to see that you are, and I've missed a blue step out up there. There should be another blue one in here on that step there. We must show it true for n equals 1. We must assume it true for n equals k. You must prove it true for k plus 1. And then you need a statement at the end. There's my statement. There's variations that I've shown you in class. Without those, they're not inductions, okay? So you're always showing it true for n equals 1 if, in this question, it says for all positive integers, 1 is our first positive integer. If it's saying for n greater than or equal to 0, this would be 0. If it's n greater than or equal to 2, that would be 2. So just be careful you read the question. So showing the next, so we've showed the left-hand side, right-hand side is true for 1. Showing it for k, we're just putting in the k for the n's, and now we're looking at n plus 1. I've used, I think it's a past HSC question. I've written my stuff over here because I like my working out a little bit better. So you can look at that. We can look at mine for the n equals k plus 1 step. All I've done is gone up to the step that was, where are we, up to here. That's my step before my last step. I've popped in k plus 1 and I've got my new part that I want it to sum to. So the left-hand side, what I've done is I know up to here, it equals to the sum that I had before, and I've added on the k plus 1 squared. It is over 3 there, so I've made this part over 3 by multiplying by 3. And then I factorised, or pulled the 1/3 out the front, factorised out a k plus 1, put my remaining terms in the bracket, factorise that, and it's just fallen out nice and easy. So that should be really simple for you guys to do. We've done lots of those in class. And that should be saying equals the right-hand side. Since we've shown that, we now need to put our concluding statement that along the line says, since it's true for n equals 1, it's also true for n equals k, and it's true for n equals k plus 1. Therefore, by mathematical induction, it's true for all positive integers. So that was for 3 marks. The second one, we were using induction to prove that n plus 1, n plus 2 is divisible by 2. It's the same marking schedule. Okay, if you got all of that out, you got 3. 2 marks if you attempted the n plus 1 case, a good attempt, okay, but you didn't quite get it out, and 1 mark if you just verified the initial n equals 1 case. So again, you need to have show for 1, assume for k, prove for k plus 1, and your final statement in there always. A few of you have not popped in the you haven't done it exactly how I've liked it to be done. So I want to be really particular about that. So make sure that you have a look at what you've done compared to what I've got done in here. So we're showing it's true for 1. We're assuming it's for k is divisible, for n equals k. We need to then show that it's multiplied by some integer p. I think I used m in class. Proving it true for k plus 1. We want to show that it is going to be k plus 2 plus k plus 3. I might put that bit in there. So you want to have k plus 2, k plus 3 is equal to 2 times some integer. That's what we want to prove. So if we were to expand that left-hand side, that's what we'd get, k squared plus 5k plus 6. If I make that look like what our expansion is up there, which is 3k plus 2, and I add on any extras, I can put my 2p in there for the piece up above, and I've got a 2k plus 4, pull out a 2, and it's divisible by 2. So that was a fairly simple divisibility one. And then we put our final statement in there. So if you had trouble with that, you need to go home and have a go at it and come and ask me if you can't understand what's happening in that one. Lucky last, final question, also worth 3 marks. This one was a little bit harder, okay. We're going to prove that 3 to the power of 2n minus 1 is divisible by 8 for all positive integers. So this is my working out. I'm showing it true for n equals 1. Okay, so I've popped that through and I've got 9 minus 1 is 8. It's divisible by 8, so it's true for n equals 1. The second step is to assume it's true for n equals k. So we want to show that 3 to the 2k minus 1 is equal to 8 times some integer m. You may also want to rearrange that. I've rearranged it to write it as 3 to the 2k is 8m plus 1. So we're assuming that, and what we're doing is proving it true for n equals k plus 1. So we're proving it true for 3 to the 2 brackets, k plus 1 minus 1 is 8 times an integer. I've changed my integer. I'm not too stressed if you make that m because we don't know what that integer is anyway. That's what we want to prove. So let's start at the left-hand side. The left-hand side is 3 to the power of 2 brackets k plus 1, which we would have as 3 to the 2k plus 2 minus 1. Now, if you've done lots of these, you will know that we also can write that as 3 to the 2k times 3 to the 2, because that would be 2k plus 2. 3 squared is 9. What I then have done is popped in 3 to the 2k. I popped in my 8m plus 1 up here that we have assumed, so that goes in there. Expanding out the 9, I'm going to end up with, where are we? 9 times 8 to the m plus 9 minus that 1, which gives us 9 times 8 to the m plus 8. Factorise out an 8. I've got 9 times some integer plus 1, and it's times by 8, so it's divisible by 8. So that's the format that we want for these. You're always trying to find a way to substitute in your case of assumption into your inductive case. So therefore our statement is true for n equals 1, k and k plus 1, and therefore it is true for all n greater than or equal to 1 by mathematical induction. When we're always going to go back and check, it says all positive integers. That's it, our positive integers. If you wanted to write instead of n greater than or equal to 1 for all positive integers, that is okay. That's your last question. go and see if you can fix up what you did incorrect in the exam.